Here we go. So we are on page 3 of our packet, and we're going to be talking about the distance formula today. Tomorrow we'll start and do a warm-up on it, and we will make a note card to help us. But today we're going to use our notes for that. So page 3, distance formula, we're going to be doing this page and the next page that go along with it. Okay, here we go. So before we get into the distance, let's do a little bit of warm-up. It says name each of the following points on the coordinate plane below. So we did this the other day. Point A, remember ordered pairs always go X and Y. So the X value is 4. So we're going to go over 1, 2, 3, 4. The Y value is 1, 2, 3, 4. So write your ordered pair as 4, 4, and make sure you're using your parentheses. Okay? Mr. Adams, do you want to touch base to make sure we're on the right page and then make sure we're good up here? All right. Next one is point B right here, and that would be to the left. So X is -3, and the Y value is down 1, 2, 3. The Y value is also at -3. I'll get in here a little tighter maybe. All right, point C, go ahead and write that down, and we'll see if we agree. Again, we should see parentheses, commas, make it in the proper ordered pair. C is at what? 3, -6? Yep, we agree. I heard it over here. Okay. And point D is in dog. It's an X value that's -5 and a +2. All right. So we've got that down. Now, the next part, before I move on, we have our little quadrants here, quadrant 1, 2, 3, and 4. So it's a nice little reminder of what we did Friday. Okay, moving on. It says here, which of the following line segments could we easily find the lengths of by counting? Okay, so we have, 3 line segments? We've got AB. I can count that, right? It's a horizontal line. 1, 2, 3, 4, 5, 6. I got 7 units. So AB, whenever you name points, you always name them with capital letters, and you put a segment symbol over it. And that states segment AB. All right, CD is vertical, so I can do that. I can count the whole units, 1, 2, 3. So CD is also one that I can count. Now, the issue is if I try to do EF. That one's at a diagonal, agreed? So can I count how many whole units it is? No, like this is a diagonal. This is a short part. So EF cannot, I'm going to make a note, cannot be counted. So if it's vertical or horizontal, I can just count the units. But if it's at any type of an angle, I'm going to have to work a little harder, and that's what we're going to talk about next. Okay. So a little terminology to get us moving in this concept. Ordered pairs are always written as X, Y. We're going to use that. When we find the length of a line segment, we are finding the distance. We are finding the distance, or how long it is from one point to another point. And that's really all I need you to write. We are finding the distance from one point to another point, and I'm going to add a little bit more on the coordinate plane. But you don't need that extra part. We're finding the distance from one point to another point. Okay, once you have that, we have one more part to fill in here. All right, so if we need to use this, if we can't find the distance by counting, then there's a formula, and it is called the distance formula, and we're going to add that to the back of our paper. And that's what we're going to make a note card on. So the distance formula. All right, so whenever you're ready, flip it over and we will fill in the information we need. All right, so today we're going to keep referencing our notes. So you're going to use this for the distance formula, but like I said, we're going to make a note card to help us. So first thing, distance D, that's what we use is D to represent it. And you have two ordered pairs. So these little 1s and 2s are called sub, like x sub 1. They're not powers. It's just saying here's your first ordered pair, here's your second ordered pair. I really shouldn't see any phones on the desk. If they're on the desk, they should be flipped over. They shouldn't be lit up and being used, okay? So first ordered pair, second ordered pair. Now, the distance formula, and I'm going to have a little room to write some extra stuff. Here is the distance formula. Big square root sign, so everything we're going to write goes underneath that. And then we're going to go with parentheses, and we take the x2 minus x1, close the parentheses, square it. So we're taking the value of this x and subtracting the value of the other x. It doesn't matter which one you make point 1 and 2 as long as you're consistent. The idea is we want to find the difference in the x's. How far did we have to travel? Then we add to it the difference in the y. So I'm going to take y2 minus y1 again and square it. Now, if you can take a minute, this is 100% the Pythagorean theorem. Pythagorean theorem you guys all know, right? A squared plus b squared equals c squared. So if I just take a quick second and I talk about that, remember in a, and you don't have to write this down, I'm just showing you. In a right triangle, we just said that A, the B, and C. So we would say a squared plus b squared equals c squared. A is the length from here to here, B is the length here, and C is that hypotenuse. Now, how would I solve this? Well, in order to get rid of it and solve for C, wouldn't I take that square root? And guys, what I want you to see is I get the length of this segment squared plus the length of this segment squared. So what is this stuff? Well, we can't count the length, how many x's it is to get across here, so we have to find the difference. And that difference is going to give me that length. And this difference is going to give me this length. And that's going to help me find that odd angled line. So we're using, if I go from here to here, how many x units is it? That's all we're doing, counting how many x's it is, count how many y's it is to go up and down, and then we square them, and then we solve for that length. So we use it differently, but it is the Pythagorean theorem. Okay, this is the formula. I want you to write this down. This is going to be your template, and I think this is going to help us. The template I want you to use, you're going to keep the square root sign, but we're not going to fill anything in except for all of the symbols. So that's what I mean by template. So we've got our square root. We know we're going to subtract these x's and then square it. We're going to add then, subtract the y's, and then square it. By having this template, I am less likely to mess up a minus, a negative sign, things like that. So I think this will help you. Now, if you do it differently, that's okay. But for people who are having trouble with this, when we sit down one-on-one, once we start getting them to do this template, I think it helps them. Okay, so let's do our first example here. Use the distance formula to find the length of EF from the warm-up. Okay, so I'm going to come back over to the warm-up. You guys don't have to flip back. We need point E, and we need it as an ordered pair, and we need point F as an ordered pair. So let's see. Oops, daisies. Point E, what is that ordered pair? It is positive 1, negative 1, isn't it? Positive 1, negative 1, so write that down. The X is 1, the Y is negative 1, okay? And point F is down here. So we would go over 4, positive 4 for X, negative 5 for Y. So what did I say? 4, negative 5? Yep, I agree. So we had to do a little work. We had to get the ordered pairs. Now, let's get our template for the distance formula. Put all this out ahead of time. That way, I'm less likely to mix something up or forget it. So that's all I'm doing. I'm just templating it. And even if you think you have it memorized, I think we should reference it. Just make sure we're doing it right. Okay? All right. Yeah. Well, hopefully this is working. Okay, good. So I want to make sure I was recording. Now, this might help you guys. I'm going to call this my x1 and my y1, so xy, and this is going to be my x2 and my y2. So when I go to fill it in, I take x2, so 4, minus x1, which is 1. Then I'm going to go to my y2, which is negative 5. And here's where we have to be careful. It's minus, and then I fill in a negative 1. So what happens when I have minus and negative? It turns into addition, right? Okay, so we can do that. Now, when I go to put this in my calculator, I don't want to put the whole thing in. So I'm going to put an equal sign here. Now, we can do this in parts, guys. We can take 4 minus 1, that's 3, square it, we get 9. We can take negative 5, we can change this, negative 5 plus 1, that becomes negative 4. So if I want to break it down, I can do that. I get 3 squared plus negative 4 squared, and then I keep going, right? And that would be 9. And what's negative 4 squared? It's not a trick question. Negative 4 squared is negative 4 times negative 4, right? Well, wait, but a negative times a negative? Positive 16. Now, the reason I brought that up is because watch this. You know I keep using all these parentheses and I brought the parentheses down? I brought it down for a reason. If I type in negative 4 and I square it, look what I did there. I put in my negative 4, I hit square, I will get negative 16, won't I? Because your calculator sees negative 4 squared as negative and then 4 times 4 because the power is only on that. And that's no good because we know that it was supposed to be negative 4 times negative 4, which gives us a positive 16. So if I use parentheses as I wrote them down, negative 4, close the parenthesis, power on the outside, there I get my 16. So I want to show you that because that's one of our easy mistakes we make. And because we put it in the calculator, we just write it down, right? We're just like, done. So be careful on that. Now, I would add up 9 and 16 and get the square root of 25. And what is the square root of 25? Just 5. So I'm going to say EF is 5 units. So that was a nice number. We didn't have to round it. Now, I don't want to do all of this work and write it all out. What I would like to do is put it in our calculators when we do the next one. I'm going to go from here to here. I'm going to put not the square root, but everything underneath the square root sign, and I want to get to the 25. So we're going to do that with our next example. Got it? All right. So let's template it out. Let's label everything. This is my x1, y1, x2, y2. And then I would like you to try, I think using that template is going to help you. So go back up to your template, fill it in. There we go. So now that I have it, let's fill the numbers in. We want x2 minus x1. So I use 8 minus 1. One of the other things that I found helps some kids because they pair up the wrong things. Some people, it helps if you sort of like pair up, okay, these are my x's and these are my y's. Because sometimes people just see the numbers like the ordered pair and they drop them in. So if that helps you do that. So 8 minus 1 and come back to your y value, which is negative 2, minus your other y value, which is negative 6. So here's where I'm going to let my calculator do all of my work. I'm going to put a little equal sign here, and I'm going to write my square root sign because I still have to square root it. So everyone's got their calculator. If not, you can do the numbers by hand, but we need calculators. If you guys don't have calculators tomorrow, like on your desk, we're losing some points here. Mr. Adams, can you give our friends that don't have a calculator one today, but we need to write their names down? So I see 3, yeah. But then I need calculators tomorrow. All right, guys. So ignore the square root sign. We brought it down. Parenthesis, 8 minus 1. Was there one over there for? Did you turn it in today or last week? 8 minus 1 squared plus parentheses, negative 2 minus a negative 6. Now I want to show you something. The minus sign is lower and longer. The negative sign down here, way down here, is shorter. What'd you say? Will you look and see if you have that paper with you somewhere?
The orange paper is not in here. You must have turned in the gold paper.
The yellow paper I took from her, and the orange one was for calculators. All right. I'm getting 65, so everyone on their calculator should have the number 65. If not, we need to see why. Did we get it? If Mr. Adams had a minute and walked around, would we agree?
Gold paper.
Yeah, I don't. Okay, so 65 should be our number. Now, we still have to take the square root of it, right? Mr. Adams, will you grab one for her to use today so we can get... All right, so second, I'm going to clear this. I'm hitting second and my square root key. Okay, so second and that key, I'm going to type in my 65. I like to close the parentheses, and the direction said round to the nearest 10. So 8.06, blah, blah, blah. 5 and up tells you to round it up, so 8.1. 8.1 units. Okay, so that's where we're at. Let's go ahead and label and template this other one. If you just got your calculator, this is the one that Mr. Adams is going to come around and check and make sure we all agree when we do this one to make sure it's in their calculator right. So x1, y1, x2, y2. Again, I think the template will help you guys. So we're always subtracting what's in there and then adding those differences after we square them. So I've labeled everything. This just helps my brain. Okay, it helps me keep everything organized. So I'm starting with the x2 because that's in my formula. You guys can be referencing back up to the top here. And that would be 2 minus a negative 6. So double check yourself. And then negative 9 minus 12. So make sure you're pairing up your y's. Okay, here's where our calculator is going to come in real handy. Bring your square root sign. That's one of the biggest mistakes. I'll have kids who will do everything right but get everything wrong because they never took the square root. All right, so we all have calculators now. Let's put this in. So clear what's in there. Parentheses. So don't put the square root, just the parentheses. 2 minus a negative 6. So make sure you're using the minus and the negative sign, or some of you just change it to plus. Square it. Everyone found where their square is? Plus, parentheses, negative 9 minus 12, close the parentheses, power of 2. All right, what are we getting? Yeah, it should be 505. Do we agree? So Mr. Adams is going to pop his head around and make sure that you guys have that, because it, like I said, I had kids, you know, they would miss a number, a negative sign, the power. We need to make sure we're putting it in right. Okay.
This is what you're putting in right here.
490.
Forget this. This is this and this.
Double check your numbers. Go like arrow up. So you can get it back by arrowing up, and then double check because it must be something.
Now, if you get to this negative here, you're going to put this negative 6 in parentheses also. And
So it should be everything under here. You got 497, so it must be like off by some. Did you get it?
I didn't get it.
Okay.
505? Yeah.
All right. When you get that 505, guys, you're going to take the square root.
Right here, just this.
The square root of 505 doesn't really. If you came up and like, oh, I need the square root of 505 yards of this, I would no idea what you're talking about. So we want to go ahead and round that to the nearest 10th because that's what the direction said. So the 7 tells me round up. So 22.5. And since we don't know what we're measuring in, I'm just using the generic term units. Okay. So if you had trouble getting that one in the calculator, once we put this in the calculator, Mr. Adams can have her make sure. Did you get it? Okay. That's why it's so important to make sure we're trying it, so we don't do those little things later and not realize it. All right, guys, in order to find the distance here, I need the ordered pairs, don't I? So here's your origin. I know it's a little bit hard to see. Go over 1, 2, 3. Okay, so x is -4. What's the y value? +3? All right, so this is my first ordered pair. My second one is 1, 2, 3, 1. Do you guys agree with me? Never, ever trust me. Always be checking along and doing your own math. All right, so we've got our ordered pairs. Now we're going to do the same thing. Let's template it, and then let's put it in the calculator after we put it in here. So there's going to be days where we're spending most of the time sort of doing notes and trying them. This is not for you guys to copy. This is when I say fill this in. This is you pretty much trying. So then tomorrow we'll do a quick recap and you'll do a worksheet. And it shouldn't be that you have no idea what you're doing because you've tried this now and we've worked out the kinks. Okay, so tomorrow will be do a recap, make a note card, and then it will be time for you to work, and then we'll be checking it. Okay, we've got it templated. I'm putting the x minus the x, so 3 minus a -4. Then I'm coming back to do the y, so 1 minus 3. All right, there we go. So again, I can do all these, I can do the math in parts, but for our sake, let's just use our calculators. We have to use them properly. Parentheses, don't put the square root sign in, bring that down. Parentheses, 3 minus a -4. Make sure you're using the right keystroke. The minus and negative look different. Close the parentheses, then the power. That's what was getting some people. Plus, parentheses again, 1 minus 3, close them. Power is always on the outside for these. I don't think I got it right. Will you, hold on, did I do something wrong? -4, 3, 3, 1. Did we write it right? 3 minus -4, 1 minus 3. So you guys agree with me? Oh, I did agree with that. I looked at the wrong problem. Okay, 53. Now, what is the nearest tenth, guys? Second and your square root sign. So second square root of 53. What would that round to nearest tenth? 7.3, yep. Good thing we're trying this together and working it out, huh, Mr. Adams?
Everyone good?
All right, go ahead and get your ordered pair for the next problem if you're waiting for us.
The ordered pair. All right.
All right, what's this low one to the left, guys? It's going to be negative what? I have -4. Is it -5? Do you guys agree with that? I wish these were a little bit darker, the axes. All right, the one to the right would be, I think, 5. 1, 2, 3, 4, 5. -2. Okay, we agree. Again, I think it helps to label. Here's my first x and y. Here's my second x and y. And let's template it. So I don't think what we're doing is hard if you have the resources, but it is time consuming and it's actually pretty easy to mess up, right? It's pretty easy to write the wrong thing down. So just take your time and let's fill it in. We're going to take our x minus x. And then, so maybe it helps you to point to it. And then I'm going to take my y minus y. So -2 minus -5. Okay, again, we could do this in pieces, but we're going to go ahead and let our calculator do all that work for us. But you have to program it right. That's the issue. So when you guys go to do this worksheet or you do a test on this, we're requiring that you show what were the ordered pairs you used. Basically what I show you in class is what I expect you to show, okay? Because if you wrote the ordered pair wrong, then everything's going to be wrong, but we would give you credit because that's what you messed up. You would lose like half a point. But if you don't show anything, you just have a wrong answer, you're going to lose full credit. So we're going to be big on making sure you show work. All right, let's put it in. 5 minus -4, close it up, square it on the outside. -2 minus -5. All right, I got 90. Mr. Adams, will you walk around and show proof of purchase here? Oh, he thinks he's all fancy with his own little calculator. I don't know if Mr. Adams can see that far, especially when you're moving it, you know. Was that your trick? All right, so I'm going to go ahead and take the square root of 90, and we need to round it to the nearest tenth. So what will we get? 9.5 units. All right, I'm happy. Well, not really, but this is good. All right, when you're ready, go ahead and flip it over, and we're going to read that next one. We've got 2 more to do. 2 more. Oh, we're golden, Mr. Adams. All right, so go ahead and read it. We're really doing the same thing. It just didn't give us a graph or the numbers. Good? Okay. So it says find the length. Guys, as soon as I'm looking for the word length, what am I going to do? Distance. Find the length of the line segment whose endpoints are -152, 170 and -201, 115. So we have no idea what this looks like on the graph. I don't need to worry about it. I know that this is my x1, y1, and what's this? x2, y2. So again, the 1s and 2s have nothing to do with the numbers. They're just saying first point, second point. Round your answer to the nearest tenth. You need to follow directions and reread questions before we turn them in. Okay, guys, let's template it. Is the template helping you? Fabulous. See, I know some things. Oh, I keep forgetting to give myself room. This one's a big one to write. All right, so get that template in, and we'll start going.
What?
Is he already done with this one? All right, guys. X2 is -201 minus X1, which is -152. Y2 is 115 minus Y1 is 170. Okay, here we go. Let's toss it all in, but keep my square root sign for later. All right, Mr. Adams, here's some big numbers. Let's see if they can handle it. He is right.
5,426.
He is correct. He's amazing. All right.
You'll put it in. Did you get Miss David?
We should get this big number, 5,426. So show Mr. Adams that. But that's not our final answer, right? We still have to take the square root of it, round to the nearest tenth. Are we good with this one? Double checking negative signs. Now, guys, listen, I wrote the number down, and this is what we expect to see on your work. But did you catch that you can do this on your calculator? Hit second square root. And if that was my last answer, did you know you can hit second and see that little negative sign right above it? It says A and S. So it will pull up the very last answer. Now, that doesn't work if you've done something else. And so the distance is approximately 73.7 units. Oh, that was not a good line.
Well, did you get it?
73.7 units.
You didn't get it.
Okay, go ahead and read the next one and see what you think. I'm going to sketch a circle to help me, but take a second and read that. Okay, so here we go. You have a point that lies on a circle. Here's my circle. Oh, that's going to be good. Oh, that's not too shabby. Oh, right. We'll put the point right there since I messed it up. And I'm going to label it the point -1, -2. Doesn't matter where you put on the circle. This is just for us. Okay, find the radius. Okay, what's the radius mean? Do you remember? I know it's been a while. So you go around the circle, there's diameter and there's radius. The halfway point. So the radius goes from the center of the circle to any point on the edge. So no matter where we connect the center to the edge, that would be the radius. I'll label that R. If we went from end point through the circle to another end point of the circle, that's your diameter. So radius is half the diameter. Now, it says the radius of the circle is what we want if the center is located at 2, -3. So basically, guys, we are finding the distance between these 2 points, the given center to the outside. I'm going to label this as x1, y1. It doesn't really matter. x2, y2. We will get the same outcome, even if you labeled them differently. Let's template it. You got what, 13? No, not 13. All right, so x1 is -1, x2 is, or x1 is 2. y2 is -2, y1 is -3. Now, if you see this minus a negative, you want to turn it into plus positive, I'm fine with that. And then let's go ahead and put it into our handy dandy calculators. Remember, leave your square root symbol so we don't forget it. And then plug it in. -1 minus 2, power of 2, plus -2 minus -3. All right, anybody have it? What we get?
10.
Yeah, it should be 10. Okay, now it says round to the nearest hundredth. Notice the directions were a little different there. So that's 2 decimal places. So now square root of 9 is 3, right? So square root of 10 should be close. Square root of 10, 3 point what? Nearest hundredth. 3.162, so the 6 would stay because 2 would drop off, right? Nearest hundredth. So the distance, or the radius, is 3.16. The radius is 3.16 units. Okay. So let me go over one more idea. I'm going to stop this recording, though.